of theta plus the square root of 3 equals 0. What we're going to do is we're going to solve this equation. And in order to solve this equation, we need to get the variable on one side and the constants on the other. In other words, we're going to take the plus square root of 3, and we're going to subtract the square root of 3. And we get tangent of theta equals negative square root of 3. Well, what's happening here now is we go back to our working backwards papers that we did last week. We're working backwards. So in other words, and this is where the unit circle might come in handy if you don't remember or you need a refresher. What value of theta has tangent equal to negative radical 3? So it's pi over 3 in the first quadrant, but we've got negative the square root of 3. So what's going to happen is on our unit circle, we're going to have a value that's in terms of pi over 3, but what quadrants is tangent negative? It's Tracy, you're right. It's negative here over there in 4, and it's negative in 2, because all students take calculus. So tangent's positive where they all the trig functions are positive, and it's also positive in the t, in the third quadrant. So we need a second quadrant angle, and we need a fourth quadrant angle that have pi over 3 in them. So what's our pi over 3 in the second quadrant? 2 pi over 3. And then what's our fourth quadrant angle? That's a pi over 3. Pi over 3. So our directions say verify each equation is true by plugging back in the values. Well, does tangent, and I'm going to go here, does tangent of 2 pi over 3 equal negative radical 3? We hope so. And does tangent of 5 pi over 3 equal negative radical 3? It's a good way to check when you're practicing or when you're taking some sort of an assessment. Let's try another. Again, solving equations. You didn't make it to pre-calculus without being able to solve an equation. What's our first step? Subtract 6. Once again, we want to get our variable by itself. When we read this, 2 times cosine of theta equals 1. So what's our inverse operation of multiplication? Division. 2 times, we're going to divide. So cosine of theta is 1/2. So now, the nice thing on this one is that cosine of theta is positive 1/2. So cosine is going to, what's our first quadrant angle for cosine of theta that equals 1/2? Pi over 3. Now, what other quadrant is cosine positive in? One more even. Fourth. But it's actually, remember, all students take calculus. So this time we need this one. So then, again, it's pi over 3, but what's our pi over 3 angle in the fourth quadrant? 5 pi. So for some of you, you might even be working ahead of me already, because we did this last week. It's just one additional step or so, because we're solving an equation. We last week were given cosine of theta equals 1/2. So now we're just putting it in our proper form so we can actually solve that equation. So a little bit different on problem number 3. Because we have a squared in this problem, but once again our process is to isolate the radical. Isolate the variable, which in this case is theta. This is 4 times sine squared of theta equals 1. So our inverse operation is to divide. We're going to divide both sides. In sine squared theta, the 4's are going to cancel out, and we're left with sine squared theta equals 1/4. Now, we've seen squared written a couple of ways, so if you're okay with it like this, it's fine. But sine squared can be also written like that. The bottom line is we need to know, how do we undo, Chloe, squaring? And what we're going to do is we're going to take the square root. So we're going to take the square root here, and take the square root there. And square rooting and squaring cancel each other out. So the square rooting, that cancels each other out, we get sine of theta. But remember, when we're taking the square root of 1/4, we need to take the square root of 1, and we need to take the square root of 4. Well, what is the square root of 1? 1. What's the square root of 4? 2. So sine of theta equals 1/2. Did I forget anything?
Sine.
Thomas? What were you saying, Ethan?
The values of the graph.
Well, we need to get the graph, but Thomas is right. When we take the square root, we need to remember that +2 times +2 is +4, but -2 times -2 is still +4. This is going to deal with positive and negative. When we take the square root, we need to deal with both the positive and the negative values. And Ethan's right. He was kind of one step ahead of us there, because we need to look at the values now. So this time we've got sine. We've done tangent, we've done cosine, so here comes sine. So what values of theta, or let's start with the first quadrant. In the fourth quadrant, Tracy? Tangent of pi over 6 is 1/2. And then we need to go to the second quadrant, because it's positive and it's negative, so what's our second quadrant angle? 5 pi over 6. And our third quadrant angle? And our fourth quadrant angle? Now, if the unit circle's still eluding you, Tracy's back there just rattling them off. Ask him how he remembered it. If that's still a struggle for you, because he obviously has somewhat. So let's skip around a little bit here. No, I think I still want to keep going here on number 4. And one of the reasons that I want to look at problem 4 is it's cosecant. So cosecant is the reciprocal of which function? Reciprocal of sine. But we don't need that right away to solve this problem. And once again, what we're going to do is we're going to isolate our theta. We're going to start by subtracting 10 from both sides. So we get 3 cosecant of theta equals -6. Well, it's 3 multiplied by cosecant of theta, so our inverse operation is to divide. And once again, these 3's are going to cancel out, and we're going to be left with cosecant of theta. We've isolated the variable. -6 divided by 3 is -2. But now, we typically haven't memorized cosecant. But that's why I asked at the beginning. Well, what's the reciprocal of cosecant? It's sine. That is the reciprocal. So the reciprocal of -2 is 1 over -2. And so you can see that negative there. So we just worked with a problem that had sine of theta equals plus or minus. So we know that theta is going to be in terms of pi over 6, but is pi over 6 going to be one of our solutions to our equation? No, because it's negative. But what quadrants is sine or cosecant negative in? 3, 4. Gracie? Okay. So then the question becomes, well, if it's pi over 6, what is our theta value in quadrant 3 for pi over 6? 7 pi over 6. And then in quadrant 4, 11 pi over 6. Again, if that seems foreign to you, pull out that unit circle. You can never look at it enough if you're still struggling to remember it. Problem number 5, and then we're going to try, you're going to try one on your own here. When we look at this, the process is still the same. We need to isolate our theta as much as possible. So we're going to add 2 to both sides. We get 3 radical 2. Sine of theta equals 3. And it's 3 radical 2 times sine of theta. So our inverse operation is to divide. When we divide, the 3 radical 2's cancel out. And we've got sine of theta. And over here, to keep it a little bit simpler here, notice 3 in the numerator, 3 in the denominator. That cancels out as well. And 3 divided by 3 is 1. Divided by the square root of 2. But we don't like having the square root of 2 in the denominator. So we're going to rationalize that. We're going to multiply by radical 2. We're going to multiply by radical 2. Then we end up with sine of theta. 1 times radical 2 is radical 2. Radical 2 times radical 2 is radical 4. But what's the square root of 4? 2. So we've got sine of theta equals the square root of 2 over 2. Do I need to go farther? And I wanted to go back and check and make sure that our signs are okay, and they are. Sine of theta. We have the variable isolated now. Theta. In the first quadrant, what value of sine, what angle of sine has a value of radical 2 over 2? Pi over 4. And then, what quadrant is sine also positive in? Quadrant 2. And so what's the pi over 4 angle in quadrant 2? 3 pi over 4. So, take about 2 minutes if you haven't done so already. I'll pause the video and see if you can get problem 6. So we won't work this out right now. We've been around, but everybody seemed to do quite well with this. If the answer ends up, for those of you looking at it on the video later on to check your answer, pi over 6 and 11 pi over 6. But let's turn over our paper to finish up here. And there's some pretty pictures on the back. Pretty pictures on the back, but I want to talk about this for a minute before we get into dealing with the pretty pictures here. So what we've been doing as we worked with our introductory unit on the trigonometry and really familiarizing ourselves with the unit circle, is we've been really being specific. We've been dealing with just our angles that are specifically on the unit circle. The pi over 6, the pi over 4, the pi over 3, the pi over 2, the 2 pi over 3, and so forth. But we are not just limited in our answers to the specific values on the unit circle. We have what are called coterminal angles. We can go around the circle more than once and come up with an answer. And so what we're going to start looking at is we're going to be coming up with a formula to come up with any answer. First of all, what's on the unit circle, and then if we add in a rotation or another time around the circle. And there's a couple formulas for this. And the first one says, if the two angles that satisfy the equation create the same line on the unit circle, keep the smaller and add a pi k after the angle. So Mr. Jarvis was teaching this lesson this morning, and he referred to it in a really good way, and he says, does the line on the unit circle form a diameter? And if it forms a diameter on the unit circle, and we'll see it in the picture here in a couple minutes, then we're going to add pi k. If our line doesn't create a diameter on the circle, then what we're going to do is we're going to add 2 pi k after each angle. So you probably are going, what the heck is she talking about? But I hope that I emphasized it a little bit, because, so here's the picture. And what we're looking at is still the same things, the working backwards here. So we look at this here and we say, well, tangent of theta equals radical 3 over 3. So what angles have a value of radical 3 over 3 on the unit circle? 5 or 6. And 7, 5 or 6. First quadrant, third quadrant. Well, let's look at our picture now. 5 or 6 is here on the unit circle. 7, 5 or 6 is here on the unit circle. And if we connect the dots, so to speak, from here to here, does that line form a diameter on our unit circle? Because it forms a diameter on there, if the two angles that satisfy the equation create the same line, that's what we just got. We've got the same line on the unit circle. Keep the smaller angle and add a pi k after it. So I went the wrong way there. So we're going to keep the smaller angle, 5 or 6, and add pi k to it. So you don't even really need to write pi over 6 and 7 pi over 6, because what that takes into account here is if we add pi, it's like adding a protractor. So there's the pi. So if we add pi k, there's ones. And then if we added another, we'd be going around and around. And we add another. We just start spiraling. And so that's what the pi k is. It's just getting us, and in fact, I should have stopped here, because it could be here or here. And then we go around here or here. And we keep going around. And end up to be here or end up to be here. This represents an infinite amount of solutions on the circle. Are you kind of sort of with me? Let's try another one. Chloe? Well, and we don't even need, all that we really need, all those times around is the pi k part. So yes, pi over 6 plus pi k. So I want to put the dots back in here in our line. And it's because we formed a diameter in the circle. We take a look at number 8 here. Secant of theta equals negative 2 radical 3 over 3. And remember, we're not as familiar with secant, but we know what we can do. What's the reciprocal of secant? Cosine. So cosine of theta. So we're going to, since we've got the reciprocal here, we'll take the reciprocal of our fraction, and it's going to be 3 over 2 radical 3, and don't forget the negative. We don't like the radical in the denominator, and in fact, hopefully some of you are going, oh, I know what this one is. We've done this one so many times. That's radical 3 over 3. So this is going to be cosine of theta equals negative 3 times the square root of 3. We multiplied the tops of the fraction together, the numerators. Down here in the denominator, when we multiply, 2 times radical 3 times radical 3 is 2 times the square root of 9. I do want to say I did move my negative up to the top, and that's okay. It's a negative fraction, so our negative can be in the top of the fraction, it can be in the bottom of the fraction, it can be in front of the fraction. If we simplify this a little bit, we have negative 3 radical 3 over 2 times the square root of 9, which is 3. And if you need to, 2 times 3 is 6. But notice 3 divided by 3 is 1. So really, what happens here is we are left with cosine of theta equals negative the square root of 3 over 2. So what angle has a value of negative the square root of 3 over 2? And if you need to, start with where is cosine the square root of 3 over 2, the first quadrant angle. So Ethan's saying pi over 6, which is true, but 5 pi over 6 is the second quadrant angle. And then what's our third quadrant angle? 7 pi over 6. Now, again, we may or may not need that, but what we want to go back and look at is, where's 5 pi over 6 on the circle? Well, 5 pi over 6 on our circle is here. And 7 pi over 6 is here. And if we connect those two values, does it form a diameter on the circle? No. So what do we do when it doesn't form a diameter on the circle? If the two angles that satisfy the equation do not create the same line, we didn't create the same line, we didn't create a diameter, keep both angles and add a 2 pi k after the angle. So we're going to take 5 pi over 6, and we're going to add 2 pi k. You need somebody to go with you. You're sick. Okay. And then 7 pi over 6, and 2 pi k. Just to distinguish one last time. Do they form a diameter or do they not form a diameter? This one doesn't form a diameter, so we have to add the 2 pi k to each angle. If it does form a diameter, then we take the smaller of the angles to get the pi k. So as we continue here, hopefully we can apply it now a little bit. Now you've seen one of each. So what happens is we go and change it. We put a plus and minus in here. But we're still working backwards on this. So the first question is what value of theta has a value of 1 on the unit circle? It's 5 over 2. then what value of theta has a value of -1 in the sine function? 3 pi over 2. So, where is that on the circle? There's pi over 2. Here's 3 pi over 2. If we connect these, do we form a diameter? We don't form. Ugh. We don't form a diameter? Here's the center of the circle. So here to here is a radii. Here to here is a radii. We actually do form a diameter. So then the question says, or then we can go and you can look back at the top of your paper. If the two angles that satisfy the equation create the same line on the unit circle, keep the smaller angle and add a pi k. So we're going to keep the smaller angle and add the pi k. Let's try one more. I'm going to skip 10 and go to 11. So when we take a look at 11, cosecant. Cosecant is the reciprocal of which function? Sine. So it's going to be sine of theta. Since we're taking the reciprocal, this is going to be 1 over negative the square root of 2. And once again, we need to get rid of that radical in the denominator. So we're going to multiply. And really by negative radical 2, if you want to get technical. Because we don't like having a negative in the denominator. So 1 times negative the square root of 2 is negative the square root of 2. Negative times negative is positive. Square root of 4. And what does the square root of 4 equal? 2. So when we simplify this, we really end up with sine of theta equals negative square root of 2 over 2. And then that's where we have to start thinking about the unit circle. Well, what values on the unit circle for sine? What values of theta on the unit circle or sine have a value of negative radical 2 over 2? Quadrant 3 and 4. That's actually the first thing that I write on my paper is what quadrants am I going to work for? So 3 and 4. So what would be our angle in the first quadrant? It would be pi over 4. And then to get to the third quadrant, Ethan's just one step ahead here. It's 5 pi over 4. That's in the third quadrant. What's our pi over 4 angle in the fourth quadrant? 7 pi over 4. So as we take a look back here on our unit circle, here's 5 pi over 4. Here's 7 pi over 4. And if we connect those, do we get a diameter? No. And when we look back here at our directions here, if the two angles that satisfy the equation do not create the same line, they don't, keep both angles and add a 2 pi k after each one. So when we come over here, 5 pi over 4 plus 2 pi k and 7 pi over 4 plus 2 pi k.